Hey there! Thanks for stopping by. Let's dive into something amazing together. Welcome to Next Gen EduBuddies. Don't forget to hit those buttons below to stay connected. Like, comment, subscribe. Let's keep exploring together.
Have you ever paused to consider what the entire world around you is actually made of? From the air you breathe to the complex devices you use, everything is built from tiny particles. These fundamental building blocks are known as atoms, the foundation of all physical matter. But our current understanding of these tiny structures did not happen overnight or by accident. It is a story of centuries of curiosity, experimentation, and constant scientific refinement. In this video, we will explore the fascinating history of the atomic model. We will journey from ancient philosophical ideas all the way to modern quantum theory. Around 400 BCE, the Greek philosopher Democritus proposed a bold and revolutionary new idea. He suggested that matter is composed of small, indivisible particles he called atomos. The term itself literally means uncuttable, implying these were the smallest possible units of nature. However, this early philosophical concept lacked any real scientific evidence to support it. Because of this lack of proof, the idea was largely ignored by thinkers for many centuries. Fast forward to the early 1800s, when John Dalton introduced the first true scientific atomic model. Dalton proposed that atoms were solid, indivisible spheres, much like tiny billiard balls. He also suggested that each chemical element consists of its own unique, identical atoms. Dalton's theory provided a way to explain chemical reactions as rearrangements of these solid spheres. This breakthrough effectively laid the foundational groundwork for the entire field of modern chemistry. By 1897, J. Thomson pushed the boundaries further with his cathode ray experiments. He discovered the electron, a tiny particle that carried a negative electrical charge. This led him to propose the famous plum pudding model of the atom. In this model, negatively charged electrons were scattered within a positively charged sphere. This was the very first model to suggest that the atom possessed an internal structure. It moved science beyond the idea of the atom as a simple, solid, indivisible object. Then, in 1911, Ernest Rutherford conducted his legendary gold foil experiment. He fired alpha particles at a thin sheet of gold to see how they would react. He observed that, while most particles passed straight through, some were deflected at sharp angles. This unexpected result led to the revolutionary discovery of the atomic nucleus. Rutherford realized the atom had a small, dense, positively charged center. He proposed that electrons orbited this nucleus much like planets orbiting a distant sun. However, this planetary model still had some limitations regarding stability and energy. In 1913, Niels Bohr refined Rutherford's model by introducing specific energy levels. He suggested that electrons do not just orbit randomly, but occupy fixed paths. These electrons can jump between levels by absorbing or releasing precise amounts of energy. This elegant concept successfully explained the mysterious patterns seen in atomic emission spectra. Yet, science continued to evolve as researchers looked deeper into the nature of matter. In the 1920s, brilliant minds like Schrödinger and Heisenberg changed the game again. They developed the quantum mechanical model, which moved away from simple circular orbits. Instead of fixed paths, they proposed that electrons exist in probability clouds. These regions are known as orbitals, representing where an electron is likely to be found. This model describes the atom with incredible mathematical accuracy and depth. It forms the essential basis of our modern understanding of both physics and chemistry. Today, we view atoms as complex, dynamic structures rather than static objects. They are composed of protons, neutrons, and electrons, all interacting in a tiny space. These components are governed by the strange and fascinating laws of quantum mechanics. It is a world where particles behave in ways that defy our everyday intuition. Research continues to uncover even deeper layers of matter within these structures. We are constantly learning more about the forces that hold the universe together. Our scientific journey into the heart of the atom is clearly far from over. The history of the atomic model shows how science evolves through constant questioning. From simple ancient ideas to advanced quantum theories, every step was vital. Each discovery has shaped our current understanding of the vast universe around us. It reminds us that even our most solid theories can be updated by new evidence. We have come a long way from the concept of a simple, uncuttable sphere. The atom remains one of the most important concepts in all of human knowledge. Thank you for joining us on this journey through the history of science. We hope you enjoyed learning about how our view of the atom has changed. If you found this video helpful, please consider hitting the like button. Sharing this video helps others discover the wonders of the scientific world. Don't forget to subscribe to our channel for more educational content. Stay curious and keep exploring the fascinating building blocks of our universe.
Don't forget to click subscribe and join the family. There's so much more coming your way. Subscribe now and never miss out on the fun.